Hi, Year 11. I am here, don't worry. So, okay, let's start again with our kit quiz today. And then if you do have graph paper, you may benefit from it today. But if you don't, line paper will be okay. It is manageable. So, kit quiz on our mini whiteboards, 1 to 5, you know the drill. Pause the video, tell me what those 5 key terms are, and be ready to go through them in just a few moments. So, pause the video. And magically, a few minutes later, let's go through the answer. So number 1, an object does not return to its original length after it has been stretched. So that's referred to as inelastic deformation. Number 2, the difference between the stretched and unstretched lengths of a spring. That's called the extension. Number 3, the point beyond which a spring will be permanently deformed. That's the limit of proportionality. Number 4, materials that are attracted by a magnet, they are said to be magnetic. And then the area around a magnet in which a magnetic force acts on magnetic objects or other magnets, that's the magnetic field, which a few weeks ago we were learning to draw. Remember, it goes from north to south and it has the little arrows to show the direction. Okay, so today we'll be looking at distance time graphs. And we want to be able to calculate speed, this time not from the equation, but from the gradient of the distance time graph, although it does incorporate parts of the equation. And if you're higher tier, we need to draw a tangent. So this is how we would do it from a curve and then draw a straight line against it and work out then the same process for the gradient. And then you need to be able to draw your own distance time graph. So that's everybody. We all need to be able to draw a distance time graph from measurements. So we'll be practicing that today. And determine speed from a distance time graph. So how would we do that? And that is what we're learning today. So here we have a distance time graph, and there's some key information that we can see. So time is along the bottom and it's in seconds, like we've said before. And then distance travelled is in meters. So we've got our x-axis along the bottom and then our y-axis up the side. And we've got 2 different colour arrows. And the green arrow and the sort of purpley pink arrow, they have different gradients. So you can see that the purple line or the pinky purple line is steeper. It has a higher gradient than the green. And so it probably then has a higher speed than the, say, object that was moving in the green line. You can see then when that green line goes flat, so between 4 and 7 seconds where that green line goes flat, that the object is at rest, it's stationary. So it could be that if a car had got to some traffic lights and the traffic light went red and then the car obviously stops because that's what you do at a red light, then that is why you're not travelling, you're not making any distance because you stopped at those traffic lights, or you've stopped to pick somebody up, or you've got home and you've stopped. So we could say, if we want to do some sort of data analysis here, we could say that the green car does not travel any further than 8 meters. We could say that the green car stops traveling at 4 seconds and is stationary for 3 seconds. And we can say that the purpley pink car is faster than the green car, and we could say that the purpley pink car reaches 10 meters traveled in just 2 seconds. That's quite fast then. So this is a distance time graph, and what we want to be able to use is the gradient of the line to work out the speed. So here then is another visual representation of that. So what we essentially have to work out is for the diagonal line, so we're looking at this region over on the right hand side of the graph, we look at the distance travelled. So I would say that the distance travelled for y goes from 100 to 400, so then that's 300 meters, and the time is between 50 and 70, so that's 20 seconds. So I would do 300 divided by 20, and then that would be my speed in meters per second. So this is at the point now where you should pause the video and just draw a sketch of this graph. So you don't have to have graph paper for this, it's just a sketch, but you'll have your line, and you don't even have to have the numbers necessarily for this sketch, but it's just the concept that your distance will be on the y-axis, your time will be on the x, that you'll be working it out from a diagonal line, and that you could draw then a triangle to show your change in y and your change in x, and from those two you work out your speed. So you don't do this from the horizontal section. So between 30 and 50 seconds, there's no point in working out the speed because you've stopped. You're not traveling any distance. So the speed at that point would just be 0. But if you wanted to do it for that first sloping section, so between 0 to 30 seconds, well then the distance travelled, the y, the change in y would be 100, and then you divide that by 30, and so you could work out the speed of that section. And I would expect the speed of that section to be slower than the speed of the section that's actually sort of described on the graph, so sort of between 50 and 70 second region. Okay? So not all graphs, though, will be straight lines, and so we need to deal with tangents. So this is actually mainly higher tier. So what you do, if you notice on the picture now, is where you've got a curve, you draw a straight line against that curve. And then you can see from the dashed lines that are drawn from that line how you would work out A, which is the distance, and how you would work out B. So you are permitted, when you get given these graph questions, to draw all of these dashed lines. And once you've got the change in A, you would divide that by the change in B, and then you would work out your speed. So this is higher tier mostly. So the tangent line is that sort of pink dashed line that's drawn against the curve. And then you take those two lines to the left and those two lines down, and you work out your change in the distance divided by your change in the time. And there you then have your speed. So that's working it out from a curve using a tangent. And again, this would be really good to draw onto your revision cards or into your knowledge organizer book when you send us your work, because this is about remembering the technique and being able to apply it. Okay, so in terms of applying then, let's do this now. So we've got the acceleration of a lift in a building. So we're going up. And so for the first one, then you have to draw a tangent on the curve. Okay, so even if you don't have graph paper, you can still sketch out this graph because you could use centimetres on your ruler to get the distances right. Okay. So this is going to take you a little bit of time. So pause the video and then draw the graph. If you've got graph paper at home, that's brilliant. And then you can draw a tangent to the curve at 5.5 seconds. So about halfway between 5 and 6 is the region where you want that straight line. Now on the other one, it was above, but this one clearly is going to be below. So you should have paused the video. If you haven't, do it now. Okay, so obviously it's quite hard to see how you've got on with these tangents. So basically, you're going to have to judge now. Does it touch the curve once? Is it in the right section of the graph? So if it looks like it's halfway between 5 and 6 and it touches the curve, then I'd give yourself 1 mark. Okay. If you've worked out these numbers, so if you've worked out that roughly the time is 4.2 seconds, although there are some other alternatives that they'll accept. So is it roughly between 4.2 and 6.4 seconds in terms of the time, and then 0 meters and 4 meters in terms of the distance? So then for the second part, we need to work out the speed. Now this is going to depend on what numbers you've got for A, which is why, again, this is going to be quite difficult to check your progress. I think if you were confident in drawing that tangent and drawing the little dashed lines and working out your changes in the two values, then it should be quite easy to mark in some respects. So roughly what you're looking to do is your distance divided by your time. So in the example, it says any number between 4 and 0 divided by any number between 6.4 and 4.2. So if, for example, you've got 2 divided by 5, technically that is within the range. Okay, so it's about your numbers being within the range given. So have you got a number between 4 and 0? So I'm looking at the line when I'm talking to you. Calculation correct, e.g. 4 to 0 divided by 6.4 to 4.2. So that's the line I'm on. And so is your number between those numbers. And then you should get an answer roughly should be 1.8 meters per second. But if you've got an answer that's anywhere between 1.6 and 2, then that would be acceptable. Okay, and then let's just check the last question. So the lift continues to accelerate between 4 and 5 meters. Show this on the graph. So you should have extended the graph upwards. So the curve continues and hits the 5 meter line at 6.1 seconds, or at least between 6 and 6.2. Sorry. So it should be that within 2 squares, you've hit the 5 meter line. And if you're not sure about how you've marked that, can you just email it to me and I can have a look at that and I can let you know. Okay, so time for the next one. So what you need to do with this is in your books, you need to write A to F. And for each of the letters, you need to tell me whether that line tells me whether the word is fast, slow, stationary, constant velocity, sorry, that's just one thing, forwards, backwards, accelerating and decelerating. So if I look at A, it's just a straight horizontal line. So what does that tell me about the speed? And some of them have got one word linked to them. Some of them have got 2 and some of them have got 3. So there's kind of no rule. It's not that they all have one word each. So just make sure you're aware of that. So there could be 2 words for, say, A. I'm not saying there are. So in your books, A to F, and then use these words below. Describe what you can see. Pause the video and then we'll come back for the answers. Okay, so A, it's stationary. So another way of saying that is that they're at rest, they're not moving. So it's just one word for that one. B, you've got a constant velocity because it's that diagonal line, and also they're moving forwards. And then C, you've got a constant velocity again for the diagonal line. And this time they're moving backwards. You could have someone returning home. D is accelerating. So it's getting faster at the end compared to the beginning because it's getting steeper and steeper. E is decelerating. So it's starting to level off and slow down. And then the last one, F, is slow. It's also moving forwards because the line's going up. And it's also, because it's a diagonal line, a constant velocity. So what you could do with these is you could draw these on revision cards and then have like something like, what does this graph show? And draw the graph. And then on the back, you could have what you needed to do, what you needed to say. Okay, so now it's time to draw your own graph. So you need to get a piece of paper. If you have graph paper, that's brilliant, use it. If you don't, you'll just have to do it in your exercise book. And you just go from this description. So you would have time along the bottom in seconds, and then distance up the y-axis in meters. And your car starts at rest, it's not moving. It then travels 50 meters in 5 seconds. So what I would do is I would draw a little cross. So I'd go along to 5 seconds, up to 50 meters and draw a cross. Then it stops for 2 seconds. So you're going to have a horizontal line at that point. And then it travels 20 meters in 4 seconds. So your time axis along the bottom, you're going to have at least 12 seconds along the bottom. And your distance, you're going to need a minimum of 70 meters. So I might go up to 80 meters. And then from your graph, once you've drawn it, you need to use the gradient and work out the speed in the first 5 seconds. And then tell me what the total distance is. So you just add them up from the question. And what is the speed of the car in the last 4 seconds? So again, work out the gradient again. So pause the video so you can get on with this and come back when you've got it all sorted. Okay, so sorry, I'm really sorry. I've just realised I haven't actually put in the answers for this question, so I should just verbally do them. So what is the speed of the car during the first 5 seconds? So what you should have done for that point then is you should have done the change in y, which would be the distance, so 50, divided by 5. So 50 divided by 5 is 10 metres per second. So A, the answer is 10 metres per second. For B then, what is the total distance travelled by the car? Well, I add up the 50 metres and the 20 metres, so that adds up to 70. So for B, the final answer is 70 metres. And then C, what is the speed of the car in the last 4 seconds? So again, I do the distance. So I would do 20 divided by 4, and then I would work that out as 5 metres per second. So sorry I've not put it on as a visual example. I don't know why I've forgotten, but those were the answers for that one. Okay then, so for this next one, you have to do the same again. So draw a distance time graph again. If you've got graph paper, brilliant. If not, just use your exercise book and do it as best as you can. Remember, time goes along the bottom. And you're going to have at least probably 120 seconds along the bottom. So ideally, you're going to go along in tens along the bottom until you get to 120 seconds. And then looking at your y-axis for distance, at least 300 meters. So you might want to go up in 20s up the side and draw your graph. Okay then, so we need to start thinking about these answers. And again, I'm really sorry, but I don't know why I've forgotten to put the review in for this. So where is Louise's speed the fastest? I'm going to start thinking it's that when she tries to go home. So to go home, she travels 300 meters in 40 seconds. So I'm just wondering if that is the fastest section. Let's get my phone out quickly. So travelling home, when it says then it starts to rain, so she decides to go home, she takes 40 seconds to get back. The answer would be 7.5 metres per second because she comes home 300 metres in 40 seconds, which answers as 7.5 metres per second. But actually looking at that first section, she travels 100 metres in 20 seconds. It's actually faster there because she's going at 5 metres per second. And then just to double check the other part of the journey, so where it says for the next 200 metres, she takes 30 seconds. So I'll just do 200 divided by 30 equals 6.6 recurring. So the fastest section was the first bit where she travels 100 metres in 20 seconds. Where was she the slowest then? That was coming home. So that was 7.5 metres per second. So that was the slowest. What is the total distance? Hopefully I can quickly work this out then with you. So she had 100 metres and then another 200 metres, that's 300. But then she has to travel another 300 home, so it would be 600. So why have I put a second B as well? What's going on today? So what's the total distance? It would be 600 because it was 300 there, 300 back. How long did her journey take? So if you add up all the times, so 20 plus 30, that's 50, plus another 30, that's 80, and then 40 seconds to get back, that's 120 seconds. So it takes her 120 seconds to travel those 600 meters, and then calculate the gradient from the different sections of the graph. So you may have already actually done this when you were working out all the different speeds, I imagine. Okay, so time then for some quick exam questions. So a student measured how the distance travelled by the wheelchair changed over time. Figure 2 shows a sketch graph of the results. So in which section of the graph did the wheelchair travel fastest? And what you're looking for here is the steepest line. So let's just give you a moment to decide, and you can either write it down on your mini whiteboard or in your book. And it was D. It's got the largest gradient. It's the steepest line. So well done if you said D. Okay, so another exam question now. I want you to work out for sections A to B, please. So sections A to B. The distance. So work out how far. I think each square is worth 1. So work out the distance and then work out the time. So how long does it take to get from A to B? Classic question. So for the distance from A to B, you should have 26 metres. For the time for A to B, you should have 70 minutes. And then what I want you to do now as well is work out from A to E. So what is the distance from A to E? So reading across from E to the distance. And then also what is the time taken to go from A to E? And if you had this as an actual question, you could be drawing on the graph. So I would draw a dashed line across from E and a dashed line down from E. So pause the video. And for those ones, you should have 42 kilometres and then the time taken 210 minutes. Okay, so we're all finished now. Sorry for the ones that I didn't add the answers in. So I need to go and change that now. And I'll see you again tomorrow.